So after the non-cyclic phosphorylation and after that cyclic phosphorylation, we are having a topic that is chemiosmotic hypothesis. It means that there is a chemical osmosis. Chemiosmotic means chemical, and osmotic which means osmosis, as you guys all know, because that just because of the hydrogen ions we will be watching out how hydrogen are there. Okay, so there is a high concentration to the lower concentration. This is a cycle. Okay, so here you can see that first of all we have started from ps2. As you guys all know, the electrons are moving from there, two electrons. After that we are having primary electron acceptor, two electrons move to there. After that forward to the pq, that was a mobile electron. Okay, hydrogen concentration was more. Okay, here, so after that it is moving to the cytochrome B6F complex, as you guys all know, through which the hydrogen ions was pumping out there from the stroma. Hydrogens are here, so this is osmosis. Okay, because of the hydrogen ions, because here the hydrogen ions are more in the lumen now. So it is moved towards the it is moving toward the, you can see that we are having a mobile electron and another, that is plastocyanin, and that was the plasto going. Okay, after that it is moving towards the ps1. As you guys all know, this is the same cycle. This is the same cycle like cyclic phosphorylation, which we have discussed in the previous video. You can watch that's too, so you can easily understand. After that the two electrons are moving here. After that it is losing the it is absorbing the light, and it will excite their electron, and the holes will be creating, so it will be filled by this. So after their electrons are moving here, two electron. After that we were having a ferredoxin. Okay, which was having a iron containing protein. Okay, after that ferredoxin we were having a NADP reductase, as you guys all know, NADP reductase. Okay, which was producing NADPS2, as you guys all know. After that here we are having a main we were having a ATP synthase enzyme, as you guys all know. Okay, so this is what this is a particle which name is the CFO CF1. What does that mean? The upper part, that is called the CFO. This is a particle, and this is the CF1. CFO is basically embedded in the this is a reaction occurring in the thallic membrane, as you guys all know. So this is the CF0 is basically embedded in the thallic membrane, as you guys see that here this. Okay, and this is working as a membrane channel. Okay, and hydrogen ions are passing through it. That's why the ATP synthesis, because the ATP synthesis is activated by the hydrogen ions, so hydrogen ions are passing through it to activate the ATP synthesis too, and to produce the ATP. Okay, so if we talk about CF1, so it is in the stromal side, because as you guys all know, this is the stromal size, and this is stromal size. Okay, liquid, and this is the thallicoid membrane. Okay, in the chloroplast. So we can say that CF1 is in the stromal side. Okay, and they contain the ATP synthase enzyme. Okay, so this is basically what this is, the lumen of thylakoid. Okay, we can say, and this is the thylakoid membrane. Let me give you one overview. These were the grana in the chloroplast, and if you consider one, that is a thylakoid. So this is the structure of thylakoid, and in this the reaction is occurring. Okay, so hydrogen ions is increasing in lumen, so that's why the osmosis is getting start and ATP synthase is activated. So that's why we are calling that as a chemiosmotic hypothesis. Okay, we are having three hydrogen will activate the ATP synthase, and one ATP molecule will produce from the cycle. Okay, so this is the reaction. Okay, so this was our topic, that was chemiosmotic or hypothesis. In the next video, we will be discussing about the introduction of the dark reaction. So till that video, the light reaction is completed. In the next video, we will be discussing about the dark reaction.